Let's take a look at modeling using variation. I guess I better get my tablet up and running. And let's take a look at the steps for solving variation problems. So solving variation problems. Now our first step is to determine the type. So determine the type. There's direct variation, and that's where it's of the form y is equal to kx. An example of direct variation. For example, if I increase the number of free points I'm going to add to tests. Now I'm not going to add any, so don't get excited. But let's say I'm just going to add 30 points onto every test just because I'm a nice guy. Well, the student's happiness goes up. So as the number of free points goes up, then the student's happiness goes up. So that's direct variation. When one goes up, the other one goes up. I guess you could have it also as one goes down, the other one goes down, but they go together. The next type is inverse, and that's where you have y is equal to k over x. Let's say I'm going to start adding or assigning 100 problems to each section for the rest of the course. Well, as the number of homework problems goes up, students' happiness goes down. So as one goes up, one goes down, or vice versa. We have joint variation, and that's where you got y is equal to kxz. You have two variables over here. Both of these are working together to increase or maybe decrease the y. Now you can have more than two variables. You can have 3 or 4 or however many. And then you got a combo, which is the mix of the above. Step 2. Pick variables that make sense. So pick variables that make sense. You don't want to use x's and y's. Step 3. Look for your one example. So look for your one example. Use it to find k. And plug k into your formula. And step 4, find what they really want. So find what they really want. Okay, let's look at some problems then. So number 1 it says daily profit P varies directly as the number of units sold in. Well, it actually has the word direct in it, so that's a direct. And typically that's of the form y is equal to kx. K is our constant of proportionality. It'll just be a number. Step 2, pick variables that make sense. Where the varies is your equals. So daily profit P varies, so P equals. K is always K, that doesn't change. Varies directly as the number of units sold in. So number of units is in. They're telling us the variable there, so that's not hard. Step 3, look for your one example. If the profit is 4,131 when 810 units are sold, comma. So if the profit is 4131, so put 4131 in for P. When 810 units are sold, I'll learn to speak here someday. So I put 810 in for N. Now we want to solve for K. That's our, there it is. Use it to find K. Well, we can divide both sides by 810 here. So we've got 4,131 over 810 is equal to K. It then says plug K into your formula. Well, here's our formula. We now know what K is, so this becomes P is equal to 4,131 over 810 N. And step 4, find what they really want. It says, what is the profit? So what is P? What is the profit when only 520 units are sold? So they're telling us the N is 520. And we'll plug this in our calculator. So I got 4131 divided by 810 times 520. And we get 2652. And that would be our answer. Let's look at our second problem. It says the gravitational attraction A between two masses varies inversely as the square of the distance between them. Well, it actually says inverse. Those key words you'll find somewhere in your problem. So it says inverse. And typically that's of the form y is equal to k over x. Well, step 2, pick variables that make sense. Gravitational attraction A between two masses varies as where E equals is. So they tell us to use A for attraction. So A is equal to k over, varies inversely as the square of the distance between them. D for distance, and square of means D squared. Now the inverse part always goes down in your denominator. K always goes up on top. Step 3, look for your one example. The force of attraction is 13.1, so A is 13.1. When the masses are 10.2 feet apart, so they're telling us D is 10.2. Now I want to use this to find K, so I'm going to multiply both sides by 10.2 squared. So I got 13.1 times 10.2 squared. Let's see, 13.1 times 10.2 squared. And we get 1362.924. That's K. We now want to plug that into our formula, so I'm going to take this right here, and where the K was, I'll put in 1362.924. Now, step 4 says find what they really want. Let's go back and read the problem. What is the attraction? So what is A? What is the attraction when the masses are 27.5 feet apart? So D is 27.5. So we got 27.5 squared down below. So let's see, we got 1362.924 divided by 27.5 squared. I don't know how many decimal places it take to, maybe 2 decimal places, I don't know. You have to read the instructions in the particular textbook we're in and see what they say. Or maybe they wanted to leave it in a fraction. I'm guessing that's decimal. Usually physics, I think, goes better with that. Let's take a look at our third example. The gravitational field F varies directly with mass m and inversely is the distance squared from the mass. So this actually says direct and inverse. This is a combo. And combos, pretty much as you read them is how you write them down. Picking variables that make sense. So gravitational field F varies. Varies is where E equals goes. So we'll have F equals directly with the mass m, so I'm going to have km, and inversely as the distance squared. So d for distance, so d squared. Now always the inverse part always goes down in your denominator. Everything else I'll put up on top. Step 3, look for your one example. It says if a mass of 200, so they're telling us m is 200, and a distance of 5, so d is 5, so we've got 5 squared, give a gravitational field of 80, so F is 80. Now we want to solve this. Now 5 squared is 25, 200 divided by 25 gives us 8, so this will be 8k. Divide both sides by 8, and you get k is equal to 10. We then want to plug that into our formula. So plug that in here. So we got F is equal to 10m over d squared. And step 4, find what they really want. It says, what is the gravitational field? So what is F? When the mass is 310, so m is 310, and the distance is 7. So we'll put 7 in for d, and we got 7 squared down there. So what do we got? 10 times 310 divided by 7 squared. Enter. And I'll take it 2 decimal places, I guess. F is equal to 63.27. And that's our answer. And I really don't have time or space for another problem there, so let me just start a new page. And let's look at our fourth problem. It says a weekly payroll in P in dollars at a small factory varies jointly as a number N of men employed, number D of days that they work. It says joint. I teach 18, 20-year-olds down at the main campus, and I said the word joint in class. Didn't faze them a bit. I had a class of older adults. I said the word joint, and it was like they were school kids. So it's funny. I would have expected it had been switched around. But anyway, reference to the legal drug. Okay, so joint variation. Now, that's typically of the form y is equal to kxz. People are funny. I think psychology would be a fascinating area to study. Weekly payroll P in dollars at a small factory varies. Varies is where equals goes. So we're going to have P equals. We're picking variables that make sense. Varies jointly is a number N of men employed. So N for number of men employed. And number D of days that they work. So D for days. Step 3, look for our one example. It says when 30 men, so that's N. When 30 men worked 5 days each, so that's D. Payroll was 2,000. So we got 2,000 is equal to 150K. Divide both sides by 150. And we get K is equal to 2,000 over 150. Now you can plug this in your calculator if you want. You can spend time simplifying it. But the truth of the matter is we're going to immediately plug it in our calculator in these problems, so you don't have to spend that kind of effort. So now we want to plug that into our formula. So replace the K with 2,000 over 150 in D. Step 4. Find what they really want. Find a payroll, so find P. When 42 men work, so N is 42, work 2 days each. So number of days is 2. So let's go see what this gives us. 2,000 divided by 150 times 42 times 2 enter. 1120. So our payroll would be 1,120. Now notice this problem. I pull these out of old. I'm not very good at making up word problems, so I look for really old textbooks that I can modify them slightly and so forth. This says weekly payroll P in dollars at a small factory varies jointly as number in of men employed. Men employed. Implies there's no women employed there. Also, they're calling it a factory. It's been a long time since we called it a factory. Days before women worked in factory or a plant, it was before World War II. So, when 30 men worked 5 days each, the payroll is 2,000. Well, that's a pretty small payroll for 30 men working 5 days. So, kind of gives you an idea how old the book is. Might have been one from the 1800s. I don't know for sure. I collect math textbooks. I got an exciting life. Okay, let's look at my happiness. I'll look this weekend. My son's going to be home. He always brings me a lot of happiness. So that'll be like up on top. He'll increase my happiness. I'll make math videos. I have no life, so that'll make me happy. My stepson will probably be home talking about how he hates his new job. So he'll reduce my happiness in that way. He'll increase my happiness in other ways, but my wife will probably be home. She I don't know if she'd be in a good mood or not. She might be in a bad mood. Been kind of working a lot lately, so she's kind of tired. So she's probably going to be cranky. And I'll probably eat Chinese at some point. I love Chinese food. That'll increase my happiness. Okay, my son's going to increase my happiness tenfold. Math videos probably increase it 2 times. Chinese food would probably be 2 times. That stepson, actually I'm not even sure if I'd put him down here. He'll whine a little bit, but unless he's having a real bad day, he probably won't whine too much. But let me put a factor of 2 there just so I have a number. And she's assuming she isn't working, she'd probably be in a pretty good mood, so I'll just put 2 there. Okay, look at our factors. We got 10 times 2 times 2. That gives us 40. And 2 times 2 gives us 4. So that gives us 10. So that would mean my happiness would increase by a factor of 10. Now that's what we're looking for in this next problem. We're looking for a factor. Not looking to solve these 4 steps. You can't do that on this last one. So let's look at this. Problem number 5. When many people claim as they get older, they can't see like me, I'm blind. Okay, many people claim as they get older, time seems to pass more quickly. Suppose that the perceived length of a period of time is inversely proportional to your age. So, time is inversely proportional to your age. T for time, A for age. Inverse part always goes in the denominator. It says, how long will a year seem to be when you're twice as old as you are now? Well, instead of A there, I'm going to put 2A. Now, I wanted to get it to look like my original one here, with the K over A. Well, I can factor 1/2 out in front. And we get that. Now, this is what we're looking for. It says, how long will a year seem to be when you're twice as old as you are now? It'll seem to be half as long. So we're looking for the factor on this. And that's the last of that problem. So let me stop the recorder here.